Hey guys, it's the midterm review for the 16-17 school year. Here we're looking at a relation that's a collection of coordinates, and we have to decide a couple things. We have to decide if this is a function, what the domain is, and what the range is. To decide if this is a function, we look at our x values. And if we have repeated x values, like 1, negative 2 and 1, 3, that means this would not be a function. Those 2 points would be graphed on top of each other, and this would violate the vertical line test. So no, this is not a function. The domain, I'm going to look for my x values. The domain is the set of all x values. So you've got 1, negative 2, we've got negative 1, and then 1 repeats, so we don't have to include that again. So the domain for this is 1, negative 2, and negative 1. The range is the set of all y values. And to do that, I'm going to look at my y values. So we got negative 2, 0, 2, and 3. Here we got to perform some function operations. We've got a function defined as h of t. Remember, that's not h times t. That's the function named h using the variable t. And we've got for h of t negative 4t plus 4. For g of t, positive 4t minus 1. H minus g of t literally means that we're taking h of t minus g of t. So when I go to plug that in, we get negative 4t plus 4 minus 4t minus 1. And when I do that, I get negative 8t. And then 4 minus negative 1 is plus 5. This is your final answer. I'd like you to notice this is not multiplying by t, and that all we're doing is combining some like terms here. Here we've got two functions again, and we've got g of n, f of n, and we're looking at this weird notation, g open circle f, which really means g of f of negative 3. In other words, g of f of negative 3. I mentioned a few times this is like my least favorite notation in all math, partly because I think it looks stupid, but it's also confusing with a couple other different ways that we deal with functions. So I wanted to make sure we talked about this because you will see this notation on your midterm. Okay, so g of f of negative 3 means I'm finding f of negative 3 first. So f of negative 3 is equal to negative 3 plus 3 equals 0. Okay, so f of negative 3 is 0. We're looking for g of 0. So I took what I got, and now I'm going to plug it in to g. And 0 plus 1 is equal to 1. G of f of negative 3 is equal to 1. That's my final answer for this problem. Here's another function composition. Again, this is that awful notation with an open circle. I'm immediately going to rewrite this as g of h of x. Okay, this time I don't have a number to plug in, so what I'm going to do is to rewrite g of x, leaving some space for what I'm going to plug in, both in my function notation and in my equation. Because for h of x, I'm going to plug in 2x plus 2, because that's what h of x is. So g of 2x plus 2 is the same as g of h of x, which means I'm plugging in 2x plus 2 in instead of x in my function g. Okay, so this is 2x plus 2, that quantity squared, plus 3. The next trick that I need to know is that this squared means 2x plus 2 multiplied by 2x plus 2. And when I distribute that out, we get 4x squared plus 4x plus 4x plus 4, and then I keep my plus 3. In other words, 4x squared plus 8x plus 7. Here we're still in the world of functions. I'm looking for more domain and range and whether or not this is a function. Domain, again, is a set of all x values. I look for my lowest one, and that looks like -5. I look for my highest x value, that looks like 7. And since we're hitting every single point between them, I'm going to write this using interval notation. This is the interval from -5 to 7 inclusive. This means the same thing as writing -5 is less than or equal to x, which is less than or equal to 7. I don't really care which notation you use, but you need to be able to understand both. The most important part is that realizing that the domain is the interval from the lowest x value to the highest x value. That whole area in between, any place we can find a piece of our graph. Similarly, we're going to do the same thing for range. So we have the lowest y value rather of -9. We've got the highest x value of +9 because that's where that guy is. I said x value meant y value. And this is the range, all possible y values, because we hit every point in between. We're looking from -9, which is less than or equal to y, which is less than or equal to +9. Those two mean the same thing. Finally, is this a function? Well, I'm going to do the vertical line test. Vertical line test states that if there are any places that I draw a vertical line and I hit a graph more than once, it is not a function. In other words, there are repeated x values. In this graph, there are no repeated x values, so yes, it is a function. Here we're looking for the domain, the range, and if it's a function. The domain of this graph, it appears to be going off in both directions. I hit every point in the middle. In fact, this looks a heck of a lot like a cosine graph, which it is. The domain for this is going to be -infinity to infinity. And we say that's -infinity to infinity because we're going to assume the graph keeps following the same behavior after it leaves the graph. So we're not talking -10 to 10, we're talking -infinity to infinity. All right, the range, I'm going to look at my lowest y value. It looks like my lowest y value is -1. So -1, and it looks like my highest y value is +1. So I'm going to make my interval from -1 to 1. And finally, is this a function? Well, if I take a quick look at the vertical line test, every single time I draw a vertical line, I only hit once. So yes, it is a function. It passes the vertical line test. Here we're trying to find f of 0, f of -4, f of 5, and f of -6. F of some letter A or some number means the height of our graph at x equals a. So if I were to find f of 0, we're looking at the height of our graph, and that has a height of 2 at that value. If I were to then try to find f of -4, so 1, 2, 3, 4, oh look, that has a height of 0 at -4. If I were to then try to find f of 5, that's 1, 2, 3, 4, 5. That looks to me like that's a height of 3. And finally, for this one, we're going to find f of -6. And I go 1, 2, 3, 4, 5, 6. Uh-oh. There's no function at f of -6. Therefore, f of -6 does not exist. When you guys take calculus, you're going to abbreviate this to DNE. Does not exist. Here we're talking about transformations. I'm going to write out the transformations that are required to get this graph from its mother function. In other words, from the basic graph of sine. This is going to have 3 pieces. We have an amplitude number that's going to affect it. We have a phase shift number, and we have a midline number. So we can think about that in terms of that. Or back to the beginning of the year, anything in the parentheses that's being added or subtracted means we're going to move it right or left. Plus means we're going to go left, and however many units that is, so 4 pi over 3. At the end, anything we're adding or subtracting to the whole thing, is going to affect the y value, and plus means up 1 unit. And the last piece of this is my amplitude, and that's going to be a vertical stretch. Each y coordinate is going to be multiplied by 9. So I'm going to say by multiple of 9. Here we're trying to find the amplitude and the period. So there are a couple things we have to deal with. The first is to know how to find the amplitude. In this case, the amplitude is going to be the absolute value of whatever number is out in front. In this case, the amplitude is just 5. The period, we know, is 2 pi over b. In this case, our b is 7. Therefore, the period is 2 pi over 7. And we're done. Here we're trying to find the amplitude and the period. This one's a little bit sneaky because it looks like that -2 is the amplitude, but in fact the amplitude is the number multiplied by the trig function, which in this case is 1. The period we know is going to be 2 pi over b. In this case, oh, that's kind of hard to feel. So that is the same as 1/7 theta. That means that b is 1/7. That was kind of sneaky. So the period would be 2 pi divided by 1/7. And we can do some fractions here. So 2 pi divided by 1/7, or 2 pi times 7 over 1, which is 14 pi. There are a number of you who have some serious issue multiplying and dividing fractions. If you come see me before the midterm, I'm happy to give you some extra work on that. We've got some function transformations. We're given a mother function, f of x is equal to x squared, and we're asked to write the function version of the words here. Okay, left 1 unit, that's going to become, instead of x squared, x plus 1 squared. For the inside, we always use the opposite, so plus 1 to go left. And translate up 3 units, that means afterwards, I'm going to write a plus 3. So left 1 up 3 is x plus 1 quantity squared plus 3. F of x equals the absolute value of x. We've got to go left 3, down 3. So that would be the absolute value x plus 3 for left 3, and then minus 3 on the outside for down 3. This is my left, and this is my down part. Okay, this is based on the same idea as any of the function transformations. The inside is going to be left 1, and the outside is going to be down 2. So our whole graph is going to go left 1 and down 2. There's my new vertex. That point is going to move left 1 down 2 to there. That is going to go left 1 down 2 to there. You have a basic shape that looks like this. We've got to find a couple things here. First, we've got to find coterminal angle. That means at the same place between 0 and 360. And we've got to find a reference angle. Let's find the coterminal one first. So at -300, I know if I go 360 around, I get to a coterminal angle, and that happens to give me 60 degrees. This also, so what we're really doing for -300 is we're looking at this angle. My reference angle means the angle I make with the x-axis. And the reference angle happens to also be 60 degrees. That's not always going to be the case, but in this case, that worked. Here we're going to find the reference angle. For radians, things tend to work out really nicely for reference angles. 11 pi over 6 negative is going to be all the way back here. And the reference angle happens to be pi over 6. For any of our unit circle values, the reference angle is going to be whatever that fraction of pi we're dealing with. So for 41, the reference angle would be pi over 4. That may not always be the case. I'm trying to think of some that are not. But for our basic angles, that will be the case. And that's because we have pi and 2 pi here. So anytime that we're going around here, we end up with some nice even multiples. For these, we're converting between degrees and radians. And the first thing I'm going to do is to convert number 43 to radians. I know that's going to be multiplied by pi and divide by 180. I could also have used 2 pi and 360, but that's not necessary. And then I'm going to do some reduction. So this is negative 285 pi over 180. I know that both of those are divisible by 5, and that gives me negative 57 pi on top, and on the bottom, 180 divided by 5 is 36. Those both happen to be divisible by 3, so I can reduce that further to get negative 19 pi and 12 on the bottom, and that's as far as I can go. For 45, I'm going to convert this to degrees, which means I'm going to multiply by 180 divided by pi. All right, 5 times 180 is going to be 900. My pi's cancel out, and I've got 12 on the bottom. I know both of these are divisible by 3. That would be 300 over 4, and 300 divided by 4 is going to be 75 degrees. Finding inverse tangent of something is basically a calculator problem. We could do this based on unit circle stuff. You have to know a couple things. First, inverse tangent looks from negative 90 to positive 90, or negative pi over 2 to positive pi over 2. Inverse sine looks along the same interval. Inverse cosine goes from 0 to pi, or 0 to 180. So tangent inverse of 1, we're in the first quadrant. The only thing gives me an angle that has a tangent of 1 is going to be 45 or pi over 4, depending on if I'm in radians or degrees. If you are on a calculator, you got to be really careful about the radians or degrees thing, and you've got to make sure that you're working on converting this back to pi's from whatever decimals you're looking at. Another inverse trig question, and again, sine is looking for the angles from negative pi over 2 to pi over 2. So we're looking for the angle down here for the negative value, and that's going to be at negative 45 or negative pi over 4. So negative pi over 4 or negative 45 degrees, both of those are fine. Here we've got some right triangle trig. Solving the triangle means I need to find all sides and all angles. First thing I'll do, 180 minus 90 is 90. Minus 22 more is going to be 68 degrees. Then I've got to find my other pieces. So I might do something like sine of 22 is equal to my opposite, b, over hypotenuse 4. So if I do, and again, making sure my calculator is in degrees, not radians, so 4 times sine 22, and I get 1.49. 1.49. All right, so 1.49, and from there, if I wanted to do a Pythagorean theorem, I could, and that would look like 4 squared minus 1.49 squared is equal to a squared. And if I do that, that's going to be 16 minus 1.49 squared, which is going to be 13.78. And the square root of 13.78 is going to be 3.7. Here we're looking at the sum or difference of angles. So 105 negative I've got to make using angles that we know. I could write that as cosine of negative 45 plus negative 60. And in looking at that, that uses the formula cosine of negative 45 cosine negative 60. Now if I use a plus, that becomes a minus. Sine of negative 45 sine negative 60. Okay. Cosine negative 45 is root 2 over 2. Cosine of negative 60 is a half. Minus sine of negative 45 is negative root 2 over 2. Sine of negative 60 is negative root 3 over 2. So we get root 2 over 4 minus negative times negative is positive, root 6 over 4. We get root 2 minus root 6 all over 4. Cosine of pi over 12, same thing I've got to rewrite as cosine of pi over 3 minus pi over 4. And that comes out to pi over 12. When I put this together, that's going to be cosine pi over 3 cosine pi over 4 plus sine pi over 3 sine pi over 4. That's going to come out to a half times root 2 over 2 plus root 3 over 2 times root 2 over 2. Altogether, that's going to be something over 4. Root 2 plus root 6 all over 4. Okay. This is the harder version of dealing with these sum and difference cosine identities. And in working with this, what we're going to have to do is do some work with triangles before we can actually use our identities. So first things first, I've got to find, based on sine of A, in quadrant 1, some triangles. So let's make a triangle. We're going to call this A. So sine of A is 3/5. Opposite over hypotenuse is 3/5. That only happens if that side is 4. That means that cosine of A would be 4/5. I know I need cosine of A because I need that for my identity. So again, for step 1, we found a triangle, and we use that to find cosine of A. Okay. Step 2, I'm going to look at my second triangle. So we've got tangent of B is 5/12. And in looking at this guy, so that's B, 5/12. 5/12, that's going to be 13 using the Pythagorean theorem. So for this guy, I need both sine B. In quadrant 3, sine B is going to be negative. So it'd be 5 over 13, negative 5 over 13. And cosine of B in quadrant 3 is going to be negative, and that would be negative 12 over 13. Again, I need all of this information before I can even approach this problem. I need this information because sine of A plus B is going to be sine A, sine B, plus, sine A cosine B, cosine A, sine B. And without doing those triangles first, I cannot do this problem. So sine A is 3/5. Cosine B is negative 12 over 13, plus cosine A is 4/5. Sine B is negative 5 over 13. That's equal to negative 36 over 65 minus 20 over 65. In other words, negative 56 over 65. I could do the same thing for cosine of a plus b using the other formula. The hard part here is getting those triangles. And again, we need those because we know we need sine A, cosine B, cosine A, and sine B. So we had to use these two to figure out triangles first. Here we've got to do some factoring before we can solve an equation. I'm going to factor out a tangent theta from both of these. So if I take a tangent theta out of negative tangent theta, I've got negative 1. If I take a tangent theta out of tangent theta, sine theta, I've got sine theta. That's equal to 0. That means that tangent theta is equal to 0. That happens that theta is equal to 0, and theta is equal to pi. And I've got negative 1 plus sine theta is equal to 0, otherwise known as sine theta is equal to 1. That happens that theta is equal to pi over 2. Those would be my solutions to this problem. I've got another solving problem. I'm going to start by moving everything to one side. So I might do minus sine theta, minus 2 tan theta, minus sine theta, minus 2 tan theta. You might notice that my 2 tan thetas cancel out, and I'm left with minus sine theta tan theta, minus another sine theta is equal to 0. I can factor a sine theta out of both of these, and and in the parentheses, then I'm going to have negative tangent theta, and then minus 1 is equal to 0. Okay, so we've got sine theta is equal to 0. That's going to happen at 0 and pi. And then I'm going to have negative tangent theta minus 1 equals 0. In other words, tangent theta is equal to negative 1. That's going to happen at my 45-degree angles in those two quadrants. So theta is 3 pi over 4, 5, 6, 7 pi over 4. Those would be my answers to this problem. Here we're looking at solving non-right triangles. My first go-to is going to be using law of sines because it's shorter, and if that doesn't work, if I don't have enough information for that, I'll go to law of cosines. Here, we're looking at some opposite sides and angles, so law of sines should work for us. So if we go sine of 118 divided by 30, and that should go with this pair, is equal to sine of A over 17. Doing the math on the left, I get 0.0294, and that's equal to sine A over 17. Multiply both sides by 17, and I get 0.500 is equal to sine A. If you don't recognize that as a special right triangle, what you need to do is inverse sine of 0.5, and that should be equal to angle A. That's going to be 30 degrees. Okay, I'm going to use the fact that in a triangle we need 180 degrees to figure out angle C. So you got 180 minus 30, we got 150 left. Minus 118 is going to be 50, minus 18, 40, minus 8, 32. All right, I'm going to set up my last law of sines ratio, but using C, and we're going to have C over sine 32 is equal to 30 over sine 118. Okay? And if I simplify that, C is going to be, so 30 divided by sine of 118, and then times sine of 32, 18. Here we're looking at solving a triangle using law of sines or law of cosines. I'm going to try law of sines first. And to check for law of sines, what I do is I see if I have any opposite sides and angles. Okay, A doesn't work. C doesn't work in that awful drawing. And now, oh man, I don't have any opposite pairs of sides and angles. That means I'm going to have to use law of cosines first. I'm going to start with A, kind of arbitrarily. And law of cosines is going to be a squared, so 29 squared is equal to b squared. That's going to be 21 squared plus c squared, that's 12 squared, minus 2 times a times c times, b times c times cosine of a. Okay? I'm going to get this piece by itself in the next step by evaluating all the squares and subtracting them. So that's 29 squared minus 21 squared minus 12 squared. And that's going to be 256. And that's equal to, we got 2 times 21 times 12. So 504 cosine of A, and that should be negative 504. I'm going to divide. So 256 divided by 504 is going to be negative 0.5079. And again, to get that angle, we're going to use inverse cosine of negative 0.5079. And we get 120.526 degrees. Okay, so 120.526. To finish solving this triangle, I am going to use the law of sines because it's a little bit less work intense than the law of cosines. Because now I have a pair I can use. So sine of 120.526 over 29 is equal to sine of c over 12. So sine of this guy divide by 29 multiplied by 12, and I get 0.356 is equal to sine c, sine inverse, and I get 20.9 is sine of c. I'm going to delete those extra places there because we don't really need them for this type of work. I'm going to start with 180, and we get 180 minus 20.9 minus 120.5. This is 38.6. Our triangle is now solved. Trying to work with finding the area of triangles, we have a couple different ways we can handle this, one of which is drawing some altitudes and doing some work with that to figure out what the height of this triangle is. The shortcut that we got from that way back when was a formula that the area is 1/2 times side A times side B times sine of the angle between them. So in this case, that'd be A equals 1/2 times 6 times 10 times sine of 53. And when I type that in, I get an area of 23.96 square feet. This is a good place to get some quick points on your exam. You will be asked one of these, and this is a really easy question if you just follow the formula that we had derived earlier in the year. Here we're being asked to graph some trig functions. And for this problem, we're looking at 3 cosine the quantity, 2 theta plus pi over 3. There are a couple things that are not ideal here. Most of all, the x scale is not going to be great for this, but that's okay. First thing I need to know is that the midline, there's no number at the end, so that's going to be 0. Second thing, we put my amplitude boundaries, 3 above that, 3 below that. This is a positive cosine. That means the graph shape is going to look like this. And these are the 5 points I'm looking for. Okay, first x value, my starting point. I take the inside, so 2 theta plus pi over 3, and set it equal to 0. I subtract pi over 3 to both sides, and I get negative pi over 3. I divide by 2, and I get negative pi over 6. That's my starting value. So that means this guy's going to be a negative pi over 6 at the top of the graph. Negative pi over 6, it's going to be somewhere like here. And at the top of the graph would have to be up here. Okay? My ending value, we're going to do the same thing. So 2 theta plus pi over 3. Set it equal to 2 pi. Do the same type of reasoning. Alright, so I'm going to subtract pi over 3 from both sides. 2 pi minus pi over 3 is 5 pi over 3. When I divide by 2, that's going to be 5 pi over 6. 5 pi over 6, that's going to be right there, right before pi. And that's going to be at the top of that 2. Okay, for my middle point, I've got to go exactly in between those two. I can't really tell in the graph where that is, so I'm going to figure out the average of these two numerically. So that's negative pi over 6 plus 5 pi over 6 divided by 2, which is going to come out to 2 pi over 6, or pi over 3. Pi over 3 is going to be a little bit less than pi over 2. And that makes sense, because that looks like it's about between those two. I'm going to do the same thing. So I'm looking for a point between pi over 3 and 5 pi over 6. I'll do the average again. So that'd be 2 pi over 6 plus 5 pi over 6. Oh, man. It's going to be like 7 pi over 12. 7 pi over 12. And the same thing down below. So negative pi over 6 plus, this one was pi over 3. Divided by 2. And that would be pi over 12. Ugh. So we end up with a graph that looks like a positive sine function going through each of those points. I need to be able to see you label these points, and I need to see the clear shape of the graph. You get some points for showing some of the work. If you identify the midline or the amplitude, or can show me where the start or end point are, you'll get points along the way. For number 97, we're dealing with sine graph, so we're going to do the same type of method. First, identify the midline, and then we're going to use the amplitude to go 4 above and 4 below. A positive sine graph looks like this, and the points we're going to identify are the beginning, middle, and end on the midline, and the quarter points above and below on the amplitude. Okay, first thing, the inside is just theta, so I'm going to take the inside, set it equal to 0, and oh, that kind of solves our equation for us. That's my starting point. My ending point, I'm going to take the inside, theta, Set it equal to 2 pi in. Okay, that's already solved for us too. Halfway between these two is going to be pi. That's my middle point. So now I've done that guy, and that guy. I'm going to go halfway to the top, halfway between them to the bottom, and make a nice smooth curve. Okay, write an equation for the following graphs using sine or cosine. Here I've got to be able to identify the important features of a graph. Cosine is usually easier for us to work with, so we'll talk about a cosine graph. I've got to find amplitude, I've got to find midline, I've got to find period, all that fun stuff. Midline might be the first thing I look for, and that's going to be whatever goes through the middle of my graph. In other words, the average of the highest and lowest y values. So 5 plus -1 divided by 2 is going to be 2. That means that my d value is 2. Okay? Second thing I'm going to identify is amplitude. Amplitude is the distance from the midline to the top, otherwise known as half the distance from the top to the bottom. The easiest way for us to tend to do this is the y-coordinate of the top minus the y-coordinate of the bottom divided by 2. So half the distance between the top and the bottom, which would be 3. That means that my A term is 3. Okay. For my C term, I'm looking for the x value of a max. The first maximum positive I'm going to use is pi over 3. So I would say that I'm going to make my C equal to pi over 3. And if you'll bear with me for a moment, I'm going to erase the bottom of this so we can see a little bit better. Zoom back in. Okay, so now we're looking, so far at our equation is going to be 3 cosine. We don't have a period yet. X minus pi over 3, and then plus 2. So finally we need a period. The period is going to be the distance horizontally between two maxima or two minima. So here I would do pi over 3 minus negative 2 pi over 3, which happens to be pi. All right, so period equals pi, and that's the same as 2 pi over our b value. In solving for b, I'm going to multiply both sides by b. I get b pi is equal to 2 pi, so b equals 2. My b value goes in front of the parentheses there, and this would be an example of one of the equations that would make this true. You'll get some credit for each step along the way. I'm kind of giving this away as a free response here, but hopefully that's not too surprising. There's a lot of stuff here I can give you partial credit for. You get credit for steps along the way and getting to the final answer. All right, we've got to solve some equations. We've got -2 plus tangent theta is equal to -3. I'm going to start off by getting the tangent theta part by itself, so plus 2, tangent theta is equal to -1. First thing I'd like to think about is what type of triangle can give me a tangent value of 1. I know that tangent is going to be the opposite divided by the adjacent. The only way opposite divided by adjacent could equal some kind of 1 value is if the opposite and the adjacent values are equal. The only type of triangle that can give us that is if we have a 45, 45, 90. Okay, so this would be a 45, otherwise known as pi over 4. And we're looking at our pi over 4 family. my candidates, my possible angles between 0 and 2 pi would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right. Next thing, I've got to figure out where this could be. So pi over 4 is up here, 3 pi over 4 is here, 5 pi over 4 is down here, and 7 pi over 4 is here. I know that in this case, my tangent value is negative. Tangent is positive in the third and the first quadrants. My two solutions would be 3 pi over 4 and 7 pi over 4. So theta equals 3 pi over 4 would be one of my solutions, and theta equals 7 pi over 4 would be my second solution. It's another solving trig problem. This one looks messier, but we're going to start by simplifying this. I'm going to break my fraction up. Rewrite this as 15 over 5 minus square root of 3 over 5 is equal to 3 plus 3 over 5 times tangent of theta. 15 over 5 is 3, minus the square root of 3 over 5 is equal to 3 plus 3/5 tangent theta. If I minus 3 from both sides, those are going to cancel out. And we're left with negative the square root of 3 over 5 is equal to 3 over 5 tangent theta. If I multiply both sides by 5, that cancels out my denominators. And if I divide both sides by 3, I end up with negative root 3 over 3 is equal to tangent of theta. The only triangle that we know that gives us a root 3 is part of it is going to be a 30, 60, 90 right triangle. So we've got root 3 over 2 and a half. This is going to be looking at pi over 3 here, pi over 6 up top, and I've got to figure out which one will give me root 3 over 3 as an answer. So then the trick becomes figuring out which angle we're looking at. Zoom out a little bit so I have a little more room. So if I were to look at tangent of pi over 3, that gives me the square root of 3 over 2 divided by a half, which is the same thing as the square root of 3 over 2 times 2 over 1, or the square root of 3. Square root of 3 is not the same as the square root of 3 over 3, so we need to use the other family of angles. Okay. I've now narrowed down my family of angles to the pi over 6 family. So that could be pi over 6. That could be 5 pi over 6. That could be 7 pi over 6, or that could be 11 pi over 6. And if I were to think about, we're looking for negative, that eliminates my first and third quadrants. My two solutions then, cross out that problem, would become theta is equal to 11 pi over 6, and theta is equal to 5 pi over 6. That's based on identifying my angle and then deciding if it's positive or negative. Here we're trying to prove an identity. In this case, we're trying to prove that cosine squared divided by cosecant is equal to sine over secant. A couple things that I could do to help kind of ease this. The first would be to rewrite this as cosine squared x over 1 multiplied by 1 over cosecant x. Often that will help us deal with things where we might have to switch things from the top and the bottom. Okay? I know I need a secant. I've got a cosine. Thankfully, I know that cosine and secant are related. Cosine squared is the same as 1 over secant squared. And then I've got a cosecant, and I need a sine. Actually, 1 over cosecant is the same as sine x. So I did two substitutions. And now, if I multiply these two together, I get sine x over secant squared x is equal to sine x over secant squared x. As a reminder, we did not touch this side, we left it alone. And our final answer was getting those two to be equivalent with each other. All right, so negative cosecant squared, cosine squared is equal to negative cotangent squared. First up, I might convert cosecant to sine. So I might write that as negative 1 over sine squared x times cosine squared x. I've only got one trig function, so maybe if I write that over 1, I'll be able to combine those two. All right, I don't know why I put two negatives. Cotangent squared x. I might combine those as a fraction, so that's negative cosine squared x over sine squared x, negative cotangent squared x. All right, and it just so happens that cosine over sine is cotangent, so we get cotangent squared x is equal to negative cotangent squared x, and we're done. Finally, we're on to some unit circle stuff. You need to be able to do these without having a unit circle in front of you, or at least one that you bring in. You could certainly draw a unit circle on your test, but this is going to be the last question on your exam for a reason. We don't want this to hold you up so you can't finish the rest of the exam. So, in terms of unit circle stuff, here's what I suggest. 1, figure out the triangle. So, for example, for tangent of 210 degrees. Okay, well 210 is going to be here. And if that's 180, that's 30 more. Okay, so I'm going to draw a triangle. That's a 30, 60, 90. And I know that 30's got to have a 1/2. 60's got to have a root 3 over 2, and my hypotenuse is 1. Tangent of that is going to be 1/2 divided by root 3 over 2, and because both of these would be negative down here, because that's the third quadrant, we'd end up with negative 1/2 divided by the negative root 3 over 2, which is negative 1/2 times negative 2 over the square root of 3. My 2's cancel out, my negatives cancel out, I end up with 1 over the square root of 3 as your final answer. We used a triangle, and we figured out what was positive, what was negative in that quadrant. Secant of 330 degrees, same type of thing. This time we're going to look at the reciprocal of cosine of 330 degrees. Okay, so first thing, 330. I'm going to go almost all the way around, and if that's 360, there's 30 left over. I've got a 30, 60, 90 again. Okay, there's my 30, 1/2, root 3 over 2. That's negative and that's positive. So cosine would be positive root 3 over 2. That means that secant would be positive 2 over the square root of 3. So I'm just flipping that over. Sine of 7 pi over 4. First thing I've got to do is figure out where this is. Well, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6 pi, 7 pi over 4 is down here. All right, and for pi over 4, that's going to be a 45, 45, 90 right triangle. So that's root 2 over 2 and negative root 2 over 2 since I'm going down. And sine would be opposite divided by hypotenuse. So sine of 7 pi over 4 is negative the square root of 2 over 2. Some more unit circle stuff for cosecant. What we're really trying to do is find the reciprocal of cosine of negative pi over 4. Okay, I'm just going to find cosine of negative pi over 4. Negative pi over 4 is going to be right here. And for that, we're going to draw a 45, 45, 90 right triangle to go with my pi over 4. So that's positive root 2 over 2 for the x and negative root 2 over 2 for the y. Secant is going to be cosine, so that's positive. So cosine of negative pi over 4 is root 2 over 2. That means that secant of negative pi over 4 is going to be 2 over the square root of 2. Sine of negative 300. Okay, negative 300 means I'm going to go clockwise almost 360, and we'll have 30 left. So this is equivalent to the sine of 30 degrees. If I draw my 30, 60, 90 right triangle, sine is opposite divided by hypotenuse, so sine would be a half. So sine of negative 300 would be 1/2. Finally, cosecant of 11 pi over 6. That means we're looking for the reciprocal of sine of 11 pi over 6. 11 pi over 6 is here. And it's almost 2 pi, but not quite. So we're looking at 30, 60, 90 right triangle. So drawing that, we get 30, 60, 90. I'll draw it this direction so that I know this should be negative a half down here, positive root 3 over 2 over there. So this sign would be the opposite, so negative a half. All right, I'm going to scroll a little bit. And looking at this, we've got, so if sine of 11 pi over 6 is negative a half, that means that cosecant of 11 pi over 6 is positive, or negative 2 over 1, or just negative 2. And since I scrolled up to it, let's talk about cosine of 0, because we don't have a good triangle for this. And the best way for us to think about this is at 0 degrees on my circle, we're looking at the point 1, 0. Hopefully we recognize at this point that cosine is always going to be the x-coordinate. And even without a full unit circle in front of you, unless you made your own, you should get that cosine of 0 is equal to 1 pretty quickly. You could also use that fake right triangle, but at this point that was a bridge to get you here, and I hope that you can work from this instead.